Hi everyone. Today we are presenting Secure Supply Chain SBOM with an AIOps malware. With this malware demo, we come with a detection, response, and recovery live demo. With me, we have Anthony and Chun-Ching. As of myself, I'm a sales specialist based in ANZ region with a special interest on security. Anthony?
Hi everyone, I'm Anthony Lin. I'm the OpenShift specialist covering Red Hat ASEAN.
Hi, I'm Zhang Jing, senior consultant. I'm working in the Singapore consultant team.
Thank you. This slide is talking about the landscape of Australia and Singapore secure supply chains. In Australia, there's an ongoing targeting online codes. And this has compromised our trusted software packages. It's become a significant threat to many critical infra and also enterprise organizations. When we attack one packages, it can be connected with dependency of other software. So quick assessment of all these threat intelligence are very important so that we can take the right actions to reduce the risk and mitigate or recovery it. Next, I will pass it on to Anthony to talk about Singapore.
Thanks, Wilson, for walking us through what is going on in Australia these days. In our case in Singapore, the Cybersecurity Agency of Singapore, or CSA, is looking at how we can get all the CII owners or the owners of the critical information infrastructure network and environment to attain the highest level of certifications under the Cyber Trust mark. We are looking at having this level 5 certifications for CII owners by the end of 2027. By having these minimum standards for the service providers, we will be able to reduce systemic risk, vulnerabilities, and strengthen the overall trust in the ecosystem. So Jing and myself, we are going to walk through a demo on AIOps, specifically in the area of malware detection and using tools like Ansible to resolve and to kill the malware that is present within the system. So we'll move on to the demo next. The demo use case that we are looking at today revolves around the BPFdoor malware, which operates as a hidden listener by monitoring all the incoming packets. Once installed, it is very difficult to detect as it remains dormant, which allows it to bypass the behavioral-based detection by most of the commonly seen endpoint detection and response system. These characteristics make it particularly effective and valuable as a backdoor, and hence it can be useful in certain environments such as the telco networks.
First is the detection. Already logs suspicious system activities on OpenShift cluster is monitored by the Red Hat Advanced Class Security. Human defined what to monitor. Event-driven event trigger. File log monitor will send a webhook to the EDA, event-driven Ansible, when a suspicious pattern is defined. The EDA will trigger intelligent remediation. EDA trigger is AI powerful workflow to analyze event and generate dynamic targeted fix. The generate playbook will based on the human-defined how to identify suspicious behavior and how to fix it, which is the natural language. The playbook will do the syntax check and the test on the testing OpenShift cluster. Once it passes syntax check and test successfully on the test OpenShift cluster, it will execute on the target suspicious OpenShift cluster to fix the malware issue. Next, we go to the demo.
We will start off with a walkthrough of the environment. In this case, we have the Apache service pod being deployed inside the test namespace. The workload will be infected with a malware later on as part of the demo. And at this point in time, it's running in the cluster that is being managed by the Advanced Cluster Security for Kubernetes, or ACS in short. ACS dashboard, as seen over here, shows different metrics such as the policy violations, images most at risk, deployment most at risk, and compliance by standards. As can be seen from the dashboard, A total of 3 different clusters is currently being managed from the ACS perspective. And the one that we are looking at where the workload is running sits inside this particular cluster called the RHACM-hub. Other than this particular cluster, ACS is also managing 2 other clusters, OCP cluster 1 as well as OCP cluster 3. If we were to take a deeper look into the workload itself from an ACS standpoint, there are several policies that have been violated by this particular workload, with the one that is most striking being the privileged container policy violation. What this means is that this particular workload is running as a privileged container inside the OpenShift environment. While not common, some of the workloads are actually running as privileged containers due to reasons such as the need to access hardware. Other information that can be seen from here could be things relating to image vulnerabilities, port reachability, the components that are useful for attackers, for instance. Other things that we are going to use in this particular demo include the Chat Root Kit tool. This is a tool that's useful for scanning Linux servers for vulnerabilities and malware. We are also leveraging on the Ansible automation platform to help us to pick out an event that is triggered when the malware is deployed on the workload. At this point in time, we do not see any instance where the event has been triggered for malware detection. As mentioned in the workflow, in order to detect the malware itself, we are leveraging on the audit D logs for suspicious activities such as socket creation and syscall. And those are actually defined by the human operator. And whenever there's such an event that happened, the file log monitoring will send a webhook to the event-driven Ansible to trigger it to run a playbook to perform a check and to remediate if it detects the specific malware. So next, we will move on to the actual demo. Okay, we will go into the pod terminal itself. So what we have over here is a terminal that allows us to perform actions on the container. So what we are simulating is a scenario whereby the threat actor has actually managed to go into the container and have planted the malware binaries into it. From here, what we can see is a list of different binaries that we have created, including one for the BPFdoor attack. If we are to look at the current processes that's running inside the container, there is no suspicious processes that is currently running. All these are the normal process that is running over here. So what we will do next is to trigger off the malware as well as to send the data. And next what will happen off is that we will trigger off the Chat Root Kit, where we can see that it is detecting a possible Linux BPFdoor malware attack. And from here, we see that the packet socket creation was detected. We can go back to the Ansible automation platform, and we can see that it has detected an event and triggered off a playbook. The file count is now 1 instead of 0. If I were to look at the jobs itself, I can see that everything finished running successfully. If I were to go into the actual job, what we can see over here is that it has targeted the host that has the problem by killing the process. So what we can see in this case are all the different things that the AI has actually performed. So we can see in this case that we are looking at a target host, in this case master 0 of the OpenShift cluster. We wanted to kill a process, and we will leverage on the Ansible playbook to call DeepSeek to help us to generate a playbook. So in this case, we are giving a prompt to DeepSeek in order to help us to be able to generate playbooks that is able to kill the actual process. So one of those things that is going on over here is that we are performing things like syntax checking, making sure that the syntax is validated and testing it on a local server, right? In this case, we have the playbook that is coming back with a failed execution. What will happen is that this will go in the loop until it generates and create a playbook that is able to perform the actual requirements by killing the process and returning the results that shows that the whole process is being killed. So if we go further down, we can see over here that we have a success where the playbook is generated. We have a verification summary showing that syntax check succeeded, execution test passed on the local host, and all the requirements have been verified. And everything has been successfully executed on the target environment. So this is what can be done using event-driven Ansible combined together with frontier models such as DeepSeek to create playbooks that is able to perform the actual task and kill the actual process itself. Thank you for watching the demo.
Thanks a lot for watching the live demos done by Anthony and Changjin. This is a conclusion slide of what we had delivered to the customer. As a Red Hat, we have a set of a guiding principle, a security framework, security controls, and we have gone through industry compliance, regulation, and certifications. And this is an ongoing process. We have a PISA product incident response team. We have a SDLC software development lifecycle plan to work through to make sure that our products are secure, stay compliant, and stay certified, and to help out our critical infrastructures. With this, I'd like to ask Anthony and Changjin for their conclusion view.
Thanks, Wilson. So from my standpoint, at least, we are increasingly seeing customers looking at things around the supply chain security and how they are able to also talk about concepts such as the importance of shifting left, looking at how we need to ensure that the packages are signed before we deploy anything into the environment. It should also be checked. In this way, we can reduce the chances of getting a malware attack. Jing, how about your thoughts?
Yeah, we would like to explore the AI power in the security domain to build up more flexible, dynamic, and robotic security guard.
Yep.
That's great to hear that. And with the AI evolving that's super fast on this, feel free to reach out to us if you have any questions after this video. Thank you. Have a nice week.
Thank you, everyone.
Great.